All right, let's talk about artificial intelligence, machine learning, and deep learning. You've heard these terms thrown around everywhere, right? And, they're often used like they're the exact same thing, but they're not. And figuring out the difference isn't just about sounding smart, it's actually the key to understanding the tech that is, right now, completely changing our world.
So what is the real difference? It's a question that honestly trips up a lot of people, even folks who work in tech. How do these three things actually relate to each other? Well, think of it like this. One is the entire universe of an idea. One is a specific method inside that universe, and one is like a high-performance engine using that method. Stick with me, and by the end of this, you'll know exactly which is which.
Okay, so to get our heads around this, let's use a really simple analogy. Think of those Russian nesting dolls. We're going to see how each of these concepts fits perfectly inside the other. We'll start with the biggest one and work our way in. First up, the biggest doll. Artificial intelligence, or just AI. This is the big one, the whole overarching field. Its goal is simple but huge, making machines behave in ways we'd call intelligent. For our analogy, AI is the entire concept of transport. I mean, every single way you could possibly get from point A to point B, whether it's by foot, boat, plane, you name it. Now, let's crack open that first doll. Inside AI, we find machine learning, or ML. This isn't the whole field of transport anymore. It's a specific approach to getting that intelligence. And here's the key difference. Instead of a human writing out every single rule, the machine learns on its own, just by looking at data. So in our analogy, if AI is all transport, then machine learning is a huge category inside it, like motor vehicles. It's a specific, really powerful way to get around.
And now for the smallest doll, the one tucked way inside. That's deep learning, or DL. This is a super specialized part of machine learning. It uses these really complex structures, called neural networks, to solve some of the toughest problems out there. To finish our analogy, if machine learning is motor vehicles, then deep learning is the Ferrari. It's the absolute cutting-edge, high-performance machine built for speed and power.
So there you have it. We've got our three layers: transport, motor vehicles, and a Ferrari. Now let's actually visualize this so we can see how this whole AI family tree really works. This lays it out perfectly, doesn't it? The biggest circle, the entire field, is AI, our transport. Then, a specific way of doing AI is machine learning, our motor vehicles. And then a really powerful technique within machine learning is deep learning, our Ferrari. See, each one is just a more specific and powerful version of the one before it. They're all connected, but they are definitely not the same thing.
So, what does it actually mean for a machine to learn? I mean, really learn. This is where you see the real magic of machine learning. It's not just some new trick, it's a totally different way of thinking about solving problems, compared to how we've been programming computers for decades.
This right here, this is the fundamental shift. This is the light bulb moment. With traditional programming, a person, a programmer, has to write out all the rules, step by step. You give the computer some data, it follows the rules you wrote, and it spits out an answer. Machine learning completely flips that on its head. You give it the data and the answers you want, and the machine itself figures out the rules. That's the magic. Okay, let's make this real with a super simple example. Let's say we want to convert Celsius to Fahrenheit. The old way, you'd have to code the exact mathematical formula. But the machine learning way, we just show it a bunch of examples. We tell it, hey, 0 Celsius is 32 Fahrenheit, 20 is 68, and so on. The big question is, can it figure out the pattern all by itself? And would you look at that? After learning from the data, the model gets incredibly close. We all know the right answer for 100 degrees C is 212 Fahrenheit. And the model, without ever being told the formula, learned the relationship and predicted 211.99. It figured out the rules just from the data. I mean, that's machine learning in a nutshell. So if that's machine learning, what about our Ferrari? What makes deep learning so special? What's going on under the hood that gives it the power to solve ridiculously complex problems? Things way beyond just converting temperatures. The secret lies in the engine of deep learning, something called a neural network. It's this complex web of interconnected nodes that's loosely inspired by how our own brains are structured. And this structure is what lets it find these incredibly subtle and complicated patterns in massive amounts of data. The kinds of patterns you need to do things like recognize a face in a crowd or understand what someone is saying. So how does this network actually learn? It's basically a simple but relentless cycle. First, it makes a prediction, it takes a guess. Second, it measures its own error, it checks, okay, how wrong was I? And third, and this is the most important part, it adjusts itself just a tiny bit so that its next guess will be a little less wrong. It just repeats this loop: predict, measure, adjust. Thousands, sometimes millions of times, getting a fraction smarter with every single cycle. But wait, how does the network know which way to adjust to get better? I mean, it can't be random, right? It's not. It uses a kind of mathematical compass, a special tool called an optimizer, to guide it. Think of the optimizer as the navigator, always pointing the network in the direction of a better answer. And just like a real toolbox has different wrenches for different jobs, there are a bunch of different types of these optimizers. You'll hear names like SGD or momentum. But the big one, the one that's basically the industry standard right now, is called Adam. You don't need to memorize them, just know that this is a super developed part of the field that makes modern deep learning so incredibly fast and effective. Okay, we've gone from the big picture of AI all the way down into the nitty-gritty of the deep learning engine. So let's zoom back out and ask the most important question of all. Why does any of this matter? Why is it so important to get this hierarchy right? This quote really just says it all, doesn't it? Deep learning is a type of machine learning, and machine learning is a type of AI. They're not different ideas competing with each other, they're layers. The Ferrari is amazing because it's a highly advanced car, and a car is useful because it's a form of transport. Each level depends on the one before it. So understanding all this isn't just about winning a trivia night. It's about really appreciating the power of the tools we're building. For the first time, we have the Ferrari of AI ready to go, and it's already changing everything. The only real question left is, now that we've built this incredible engine, where are we going to go next?